So when we look at this warm-up, we're trying to find the volume. We're trying to compare the volume of a pyramid to the volume of a prism. So let's start by just writing down our volume formulas. Remember yesterday when I did the experiment with the water and the prism and the pyramid, how many pyramids fit into my prism? 3, okay? So the volume of this one is base times height divided by 3, and the volume of this one is simply base times height. And we want those to be equivalent. Now, we do know some information, so let's plug in the information we know. For the pyramid, we know what capital B is. Yay, Helaman! So what's capital B for the pyramid? Let's plug it in. What'd y'all get? Remember, capital B stands for area of the base. Thank you, Hussein. 16. So instead of B, I'm going to write 16. The height of the pyramid, oh, we were nice to you. We gave you the height, is 9 divided by 3. So we can actually find the volume of the pyramid. 16 times 9 divided by 3. So we've got 48. Then, what do we know about, oh, that's weird. Okay, this is the base right here then. Here we go. It does say it's a square base, so we can find capital B of the prism. What's capital B for the prism? Capital B stands for area of the base. Earth to 8th graders. What is capital B for the prism? Oh, Hussein, you're just stealing the limelight. Very good. 4. And then we don't know the height. So what we've got here is a very easy algebraic problem. 48 equals 4h. Whatever h is would force our volumes to be equal. So how tall does that prism need to be to have equal volume to the pyramid? Very good. 48 divided by 4. So that needs to be 12 unit tall prism to have equal volume as the pyramid. Did y'all get 12 before I started explaining it? All right, here are your prisms homework answers. Okay, I'm going to go to page 2. I hope that you have answers to check. Please tell me you're actually checking answers. So you need things like P, you need an H, you need a B. And that's all you need for this one because it's not a pyramid, there's no slant height. So that's good news. So P stands for perimeter of the base. The good news is we get to use this 5, it goes here and here. And we get to use this 3, it goes here. So when we're finding perimeter of the base, we're just adding up 5 plus 5 plus 3 plus 9. So what, 12 plus 10, 22? H, when you plug into formulas, 3D solids formulas, the H always stands for the height of the prism. The height of the prism. Now I realize that's confusing because the base has its own height and then the prism has its own height. But the height of the prism, we went over this yesterday, it's whatever number connects the base to the base. What number connects the trapezoid to the trapezoid? And in this case, it's 7. And then capital B is the hardest part. Capital B stands for the area of the base. In our case, the base is a trapezoid. It's going to change. It's like a chameleon. It changes color depending on its surroundings. So right now, the base is a trapezoid. How do you find the area of a trapezoid? Well, boom. There you go. So now let's plug in what we know. We know that 3 is a base. 9 is a base. The height is 4 and divided by 2. Y'all got lucky because you didn't have to find any missing values. We gave you all the pieces to the formula. So 3 plus 9 times 4 divided by 2, and you get 24. Now that we have these pieces, we only have to just look at our formula chart and plug in what they say to combine. So LA is P times H. 22 times 7. P times H. SA is PH plus 2B. So you take the 154 that you already found, and then you add double 2 times 24. Double the base. 2 times 24. Oops, sorry. Just make sure. 154, 202. Okay. We're doing it right. And then finally, the volume, base times height. You already have the base, it's 24. You already have the height, it's 7. And so that's how we get 168. Did I clear up what you were asking about? Let's go to the pyramids homework answers. Pyramids homework. On this one, you might have gotten 13.5 root 3, and that would be okay. Yes, I can do 8. By the way, it's hard when we type these. This is square root of 3 over 2x. So that should have had parentheses around it. For number 9, is it right if you put 25 root 3 over 4? Yes. That is the same as 25 fourths root 3. The root 3 can go in the numerator. That's perfectly fine. Yes. Okay, next page. Oops, there is no next page. Okay, that's all of them. All right, sorry. So we're working number 8, okay? So looking at number 8, I mean, this one's challenging because it's got x in it instead of numbers, but that's okay. So we do know that this is a square pyramid, so that's good to know. And we know that the slant height is x, and the base edge is x. All right. So now we need to find the height. And we know that the height, the slant height, and the apothem form a right triangle. Here's the slant height, here's the apothem, and then that's what we're looking for. Now, how did I get 1/2 x? I took the base side, which is x, and I cut it in half to get this right here. This would be 1/2 x. All right, so we're going to do Pythagorean theorem. X squared minus 1/2 x squared, and that's going to equal our height squared. So if we pretty this up a little bit, we get x squared minus 1/4 x squared. There's a 1 sitting in front of x squared. I'm doing an algebra lesson right now. I'm not really doing a geometry lesson, by the way. What's 1 minus 1/4? Well, it's 3/4. Now here comes the interesting part. 3/4 x squared equals h squared. We don't want h squared, we want the height. So the last step of Pythagorean theorem is always to take the square root. So we have to take the square root of that. So the square root of 3 is the square root of 3. The square root of 4 is 2. The square root of x squared is x, and that's how we get that for our height. I'm going to stop there. You can plug the rest in to get the LA and the SA. That was probably the hardest part, was getting that height. When you square root 3/4 x squared, you get square root of 3 over 2x. Because 4 is a perfect square and x squared is a perfect square. All right, we're going to talk about cross sections really quick. Because this is part of this unit, although you probably are familiar with a cross section. So a cross section is pretty much, let's use my coffee cup, my favorite thing in the whole world. It's pretty much when you take a 3D solid and then a plane intersects the solid, and it's asking what 2D shape is formed. So a cross section, if we don't specify, you can just assume that it's parallel to the base. So the cross section of a cylinder would be a circle. Because when you slice, if you slice through the cylinder, what 2D object will you be staring at? It would be a circle. The cross section of a cube, I know I'm babying you and this is really easy. Cross section of a cube is a square. But, very good. But you don't always have to cut parallel to the base. So we might ask you, what are all the possible shapes that I could come up with when I do a cross section of a shape? So look, if I take a cube and I slice it diagonally, I could get a triangle. I don't have to get a square. So I just wanted you to be aware that you can get all different cross sections depending on what angle you're cutting the solid at. Cross section of a sphere, well, if you're going to go through the center, it'll be a circle. If you don't go through the center, you could get an oval, an ovular shape. So let's take a look at this. What can result when a plane intersects a cylinder? So I want you to think about what cross section. I love this website because this really shows you when you are cutting through a 3D solid. Over here it shows you what 2D figure you get. So this is not really anything at all right now. But what you can do is you can drag these at the bottom. You can rotate it. Ooh, ah. So when I rotate this, well, there's our circle. There's our oval. Whoa, what if I go all the way this way? What if I cut through it that way? I get a rectangle or a square. So you can cut a cylinder and you can get a square. You can cut a cylinder. Let's make it. There we go. And you can cut a cylinder and you can get a rectangle. So when we look back at this right here, what do you want to put in the yes column? What can you get when a plane intersects a cylinder? An oval, a circle, a square, we went through that, yep. A rectangle, okay, now we haven't really talked about this concept in this class because we're going to get to it next unit. But what if you had your cylinder and you had a plane and that plane touches the cylinder, just sweeps the cylinder. It just barely sweeps it. What object would be formed if it just touches it once? This is called being tangent. This is a plane tangent. Good. A plane tangent to a cylinder. And then, what if I just touch it once like this? Boom, one time, that's it. Point. So, triangles left all alone in the no column. A triangle, you cannot get a triangle by intersecting a plane with a cylinder. Okay.